The Earth is always moving and changing. It travels around the Sun and spins on its axis, but at the same time the different elements which make up the Earth are also in continuous motion. Most important are the tectonic plates which fit together to form the outer crust of the Earth's surface. Each movement causes different impacts, including constant alterations to the Earth's surface and some devastating consequences near where these plates meet. Paste the paper in your books and write down the new words on the sheet. Add extra information if you want to. Consequences. A result, effect, or impact on something. Surface. The outside or upper layer of something. Segment. A piece or section of a whole. Tectonic plates. The pieces of rock which make up the segments of the Earth. Alteration. A change or adjustment to something. Devastating. The capability of wreaking complete havoc or destruction. Example. Aftermath of a tsunami. Lesson 5. The structure of the Earth. The Earth is unique and its composition makes it very interesting for geographers to research and understand how it fits together. Interesting facts about the Earth's layers. The crust surface is plus or minus 40 kilometers in width and makes up 1% of the Earth's volume. The mantle makes up plus or minus 85% of the Earth's mass. The inner core is the warmest part of the Earth. Let's study all the layers and the composition of the Earth. Paste the layers of the Earth image in your books and copy the information. Our planet is made up of different layers of rock and magma. In the above diagram, you will notice that the innermost layer or core of the Earth is solid. However, the only reason for this is the immense pressure of the outer layers. Namely, the outer core, a viscous liquid of various metals, and inner and outer mantle, and an extremely hot layer of molten rock known as magma. Let's look at the layers in more details. You will be asked to summarize the core, mantle, and the crust. The core. As you can see in the diagram, the core is the deepest layer of the Earth. The core is divided into two parts, the inner core and the outer core. The inner core is the center of the Earth. It is also the warmest part of the Earth with temperatures of up to 500 degrees Celsius. The inner core is solid and consists of iron and nickel. The outer core, which surrounds the inner core, is liquid and also consists of iron and nickel. The mantle. The mantle is the widest part of the Earth and lies between the core and the crust. It also consists of two parts, the upper mantle and the lower mantle. The lower mantle lies between the upper mantle and the outer core. Where it borders the core, the temperature can reach up to 4000 degrees C. It is a solid layer that consists of minerals rich in magnesium, iron, silicon, and oxygen. The upper mantle is semi-molten. It also consists of minerals rich in magnesium, iron, silicon, and oxygen. The crust. The crust of the Earth's surface ranges from 6 km to 40 km in thickness. The crust is divided into the oceanic crust and the continental crust. The thin part is the oceanic crust, which mainly consists of igneous rock rich in iron and magnesium. The thicker crust is the continental crust, which consists mainly of granite. It is rich in feldspar, quartz, and silica. It forms the continents on which we live. The crust, as explained earlier, does not consist of solid rock. Instead, it is subdivided into various parts that fit together like pieces of a puzzle. These parts are known as tectonic plates. They float on the liquid magma underneath, which is why the plates are constantly moving. The tectonic plates move an average of 3 cm to 5 cm per year. Write the new words in your books on the sheet. Magma. A mixture of molten and semi-molten rock and particles beneath the Earth's surface. Circumference. The edge or outline of a shape. Pangaea. A land formation which formed the Earth's supercontinent before the continents we know today were formed. Radius. A line from the center of a circle to its circumference. Viscous. A very thick, gluey, or sticky liquid which seems to be in between a liquid and a solid. Now that you know what layers the Earth consists of, you know that we live on the crust. There are 7 large tectonic plates, namely North American Plate, Eurasian Plate, African Plate, South American Plate, Pacific Plate, Australian Plate, Antarctic Plate. These plates consist of 2 types of materials, namely oceanic and continental crust. Remember that the plates float on liquid magma, which is why they are constantly moving. Sometimes the plates collide, or move away from one another. Paste your card in your book and fill in the different plates. There are 3 ways in which tectonic plates can move. Tectonic plates can move towards each other and collide or converge. The Cape Fold Belt was formed in this manner when the South American and African plates collided when Pangaea was formed. Tectonic plates can move away from each other or diverge. The Great Rift Valley in Africa was formed in this way. Tectonic plates can move past each other or transform. They usually shift smoothly past each other, but sometimes they get stuck and pressure builds. If the plates break free after a period of time, it releases a lot of energy, resulting in earthquakes. Paste the paper and summarize how each plate moves. Go back to the explanation if you have to. Paste Activity 12 and answer the questions fully. Bring the activity to me afterwards to mark. Good luck. Continental drift. As the tectonic plates are continuously in motion, the Earth's continents are also moving gradually. These plates consist of solid rock and float on the mantle below and move at different speeds, in different directions. Millions of years ago, the land formation of the Earth's surface was very different from what we know it to look like today. It was once a supercontinent, known as Pangaea. It broke apart into Laurasia, which held what we know today as Europe, Asia, and North America, and Gondwanaland, holding what we know as South America, Africa, India, Australia, and Antarctica. Notice, on the map below, how Africa fits neatly between North and South America. The image on the screen shows how the continents moved over millions of years to what we know the world as today. Disaster areas. Because of the structure of the Earth, disasters are more prone in certain areas of the world. Study the following map to see where these areas are. Areas located within the disaster areas will experience the impact of natural disasters much more than areas located outside of these places. When you study the map, pay attention to the fact that the world's most densely populated areas are close to or within these areas. List these areas and cities in your workbook. Write the new words in your book. Cross-section. A shape or diagram which is exposed by cutting straight through something. Example. Cross-section of an orange. Continental drift. The gradual movement of the continents across the Earth's surface over a long period of time. Paste the activity and see how many questions you could answer. Bring your activity to your tutor to mark. Lesson 6. Earthquakes. We know that earthquakes can be destructive, even claiming the lives of people and animals. Earthquakes are caused by the friction, rubbing, and divergence of tectonic plates, as explained in previous lessons. Each year, plus/minus 10,000 people lose their lives due to earthquakes. There are approximately 500,000 earthquakes annually, of which 100,000 are strong enough to be felt and 100 cause damage. Scientists have done extensive research over the years to try to predict earthquakes in order to warn people in an area sooner, thus preventing loss of lives. Stronger buildings are built using reinforced material to better withstand earthquakes and minimize damage. In the picture, we can see a world map showing global cities and earthquake areas. The yellow dots show important cities around the world, such as Los Angeles, Tokyo, Beijing, London, Cairo, Johannesburg, and Sydney. The red dots and red lines show where many earthquakes happen. These red areas are mostly found along the edges of tectonic plates, where the plates meet, move, push against each other, pull apart, or slide past each other. This is why many red areas appear around the Pacific Ocean, especially near places like Japan, Indonesia, New Zealand, and the west coast of North and South America. This area is often called the Ring of Fire because it has many earthquakes and volcanoes. The map helps us see that earthquakes do not happen evenly everywhere in the world. They happen more often in certain areas where the Earth's plates are active. Causes of earthquakes. Earthquakes occur because of a release of the pressure created by the friction of two tectonic plates rubbing together, as shown in the diagram below. The place where two of the Earth's tectonic plates meet is known as a fault. This movement is not always smooth and sometimes they get locked together. The longer the plates are stuck in this position, the more pressure builds. When this pressure is released, it creates shockwaves which disturb the Earth's surface in the form of an earthquake. Earthquakes are experienced along faults, particularly along faults in the Pacific region.
The cool, rigid outer layer of the Earth, the lithosphere, is broken into massive plates. There are about a dozen major plates and many smaller plates in continuous motion as they collide with, slide under, or move past each other in a process known as plate tectonics. A plate may be entirely oceanic lithosphere, like the Pacific Plate, or, like the North American Plate, can be part oceanic and part continental lithosphere. We will return to lithosphere types in a minute, but first, let's look inside the Earth to clarify the layers. The mantle is a 2,900 kilometer thick, high magnesium silicate rock layer located between the crust and the core. The uppermost part, the lithospheric mantle, is cooler and more rigid than the deeper mantle. It lies above a hotter and more ductile layer of similar composition called the asthenosphere. As an analogy to how rock can either be brittle or ductile, consider a taffy bar like the Big Hunk. When force is applied, they are brittle when cold and ductile when warm. Zooming in to a tectonic cross-section, we see that the lithospheric plates are composed of crust on top of the outermost rigid part of the mantle. Although the mantle has a different composition and higher density than the crust, these two layers migrate as a single mechanical layer called a lithosphere or tectonic plate. This is where earthquakes occur as the brittle rock that makes up the plates fractures and breaks. The hotter, more ductile asthenospheric rock does not fracture to produce earthquakes. Continental lithosphere, with continental crust above lithospheric mantle, typically ranges from 150 to 200 kilometers thick. Continental crust stands above sea level because it has an average thickness of 40 kilometers and is mostly made of more buoyant, silica-rich, low-density granitic, sedimentary, and metamorphic rocks, which form the continents. Oceanic lithosphere, formed at spreading ridges, is typically 50 to 140 kilometers thick. Oceanic crust is only around 8 kilometers thick and is denser than continental crust because it contains less low-density silica and more high-density iron and magnesium. Thus, it forms the ocean floor with its top surface below sea level. Relative motion between plates can be broadly grouped into three main categories: transform, divergent, and convergent. Returning to the world map view, we show transform or strike-slip boundaries are places where plates move horizontally against each other. Divergent or constructive boundaries are places where plates move apart from one another. And places where plates press into one another are called convergent or destructive boundaries. Lithosphere is neither created nor destroyed along transform boundaries, which connect segments of spreading oceanic ridges and other plate boundaries. Transform boundaries can also cut across continents, as the San Andreas Zone does in California, where it connects the East Pacific Rise to the Cascadia Subduction Zone. Shallow earthquakes on long transform boundaries that cut continental crust can approach magnitude 8, whereas those on oceanic transform boundaries tend to be much smaller. At divergent boundaries, oceanic crust forms at spreading ridges where plates pull away from each other. A small volume of the mantle melts to create the crust. The hot, buoyant, upwelling mantle supports the oceanic ridges that form the Earth's longest mountain systems. Because temperature increases rapidly with depth at divergent boundaries, there is only a thin layer of brittle rock to fracture in earthquakes. Most earthquakes occur within the upper 10 kilometers and have magnitudes that are generally less than 6. More than 75% of all earthquakes occur on or near convergent boundaries. Here, an oceanic plate is forced beneath the continental in a process called subduction. Indeed, the world's largest earthquakes occur near the shallow edge of the boundary where magnitude 9s have been recorded. At this location, stress builds up over tens to hundreds of years until it releases like a spring and can produce tsunamis. A broad zone of shallow earthquakes occurs within the overriding plate due to compressive forces near the convergent boundary. Earthquakes can reach depths of 700 kilometers within the subducting plates because the oceanic plate can remain cold and brittle as it dives into the deeper mantle. Similar processes occur when an oceanic plate subducts beneath another oceanic plate. Here, an ocean trench marks the location where the plate is pushed down into the mantle. In this case, the line of volcanoes that grows on the upper oceanic plate is an island arc. Not all convergent boundaries involve subduction. When the continental parts of converging plates come together, neither can subduct. Instead, the two continents collide, producing horizontal deformation and uplift in the continental crust to build mountains and plateaus. Frequent shallow earthquakes in the continental collision zones can exceed magnitude 8 and are generally less than 40 kilometers deep. In addition to these three boundaries, there are also diffuse boundary zones in which deformation occurs over a wide region. Although less common than earthquakes along plate boundaries, earthquakes in the interior part of plates, called intraplate earthquakes, do occur. Nevertheless, tectonic activity and earthquakes are chiefly concentrated at or near plate boundaries, where many geologic features including volcanoes, mountains, trenches, and tsunamis are in a constant state of change.
The magnitude and destruction of an earthquake is measured on the Richter scale. Every level on the scale is 10 times more powerful than the previous and therefore causes much more destruction. The scale was developed in 1935 by Charles F. Richter of the California Institute of Technology. Earthquakes that measure equal and lower than 2 on the scale are known as microearthquakes, and those measuring 8 or higher are known as great earthquakes.
How a seismograph works. A seismograph is an instrument used to measure the movement of earthquakes. A weight is suspended in a way that allows it to remain still when the ground moves. Most modern instruments use an electromagnetic mechanism for this. A writing instrument is attached to the weight, allowing it to record the movement as it happens. The word graph refers to the writing action. Most modern earthquake monitoring uses seismometers, not seismographs, and record the movement of the earth digitally, or output the data to a seismogram, a printed version of the wavelengths on a large drum. These wavelengths that represent Earth's movements are so small that in order for scientists to study them, they have to be amplified.
Let's write the new words in your books. Earthquake. A sudden release of energy in the Earth's crust, which usually occurs at the edges of tectonic plates. Boundary. The place where 2 of the Earth's tectonic plates meet. Focus. The point of contention within the Earth's crust, where the pressure built by friction is released. Epicenter. The point on the Earth's surface, above the focus, which feels the effects most drastically. Magnitude. The strength or reading on the Richter scale of a specific earthquake. Seismic waves. A wave of energy that is formed and released by an earthquake. Seismograph. A device used to measure the strength of incoming waves. It allows scientists to determine the possible impact of a coming earthquake. Displacement. A change in place or position from where something was originally. Let's listen to 9 interesting earthquake facts. The largest recorded earthquake in the United States was a magnitude 9.2 on the Richter scale that struck Prince William Sound, Alaska on 28 March 1964. The largest recorded earthquake in the world was a magnitude 9.5 on the Richter scale, in Chile on 20 May 1960. The earliest reported earthquake in California was felt in 1769 by the exploring expedition of Gaspar de Portola while the group was camping about 48 kilometers southeast of Los Angeles. The Ring of Fire, also called the Circum-Pacific Belt, is the zone of earthquakes surrounding the Pacific Ocean. About 90% of the world's earthquakes. It is estimated that there are 500,000 detectable earthquakes in the world each year, of which 100,000 can be felt. Only 100 of them cause damage. Most earthquakes occur at depths of less than 80 km from the Earth's surface. The world's deadliest recorded earthquake occurred in 15 FYFTY6 in central China. It struck a region where most people lived in caves carved from. The earliest recorded evidence of an earthquake has been traced back to 1831 BC in the Shandong province of China. But there is a fairly complete record starting in 780 BC during the Zhou dynasty in China. The interior of Antarctica has ice quakes which, although they are much smaller, are more frequent than earthquakes. The ice quakes are similar to earthquakes, but occur within the ice sheet itself instead of the land beneath the ice. Effects of an earthquake. The effect of earthquakes and their aftershocks can be felt long after the actual earthquake. The impact can be divided into short-term or immediate effects, and long-term or secondary effects that occur as a result of something the earthquake had caused, such as a tsunami or damage caused by the original earthquake. Copy the mind map into your books. Effects of earthquakes. Tsunamis. Caused by underwater earthquakes. Fires. Injury and death. Homelessness. Disruption of transport and communication. Disease. Where there is no access to fresh water. Landslides and avalanches. Caused by disruption to the landscape. Loss of income and investment in an area. Damage to buildings, roads, and service delivery systems such as water and electricity. High costs of rebuilding and recovery. Loss or disruption of access to medical supplies. This road was destroyed after the earthquake in Sendai, Japan in 2011.
So let's quickly just look through the world's largest earthquakes and the effects they had. So in 1960 in Chile, approximately 1,655 were killed, 3,000 were injured, 2 million homeless. A tsunami caused 61 deaths and cost over $1.135 million in damages. That had a magnitude of 9.5. In 1964, in Alaska, a violent earthquake which only took 131 lives because of the new amount of people staying in the area and caused about $2.3 billion worth of property loss. Earthquake effects were heavy in many towns, but the secondary effects were even worse, namely landslides and avalanches. That had a magnitude of 9.0. In 2004, in Sumatra, Indonesia, in total, roughly 227,900 people were killed or were missing and presumed dead, and about 1.7 million people were left homeless because of the earthquake and tsunami, which followed and impacted over 14 countries in South and East Africa. That had a magnitude of 9.1. In 2011 in Japan, roughly 15,703 people were killed, 4,650 went missing, 5,300 were injured. At least 32,400 buildings, 2,100 roads, and 56 bridges and 26 railways were destroyed or damaged by the earthquake and tsunami. The total economic loss in Japan was estimated at $309 billion. Electricity and water supplies, telecommunications, and railway services were disrupted, and several reactors were severely damaged at a nuclear power plant near Okuma. This also forced many people to move from their homes because of the radiation leak. In 1952, in Hawaii, the sea-bound earthquake caused a massive tsunami which caused damage to property that was estimated between 800,000 and 1 million US dollars. Fortunately, no lives were lost. However, boats were beached and piers, houses, buildings, and roads were damaged. In 1906, in California and Central America, the Ecuador, an earthquake off the coast of Ecuador and Colombia generated a strong tsunami that killed between 500 and 1,500 people there. However, the impact were felt all along. The impacts were felt all along the coast of Central America and as far north as San Francisco and west to Japan. In California, hundreds of buildings burned down, and as a result, hundreds and thousands of people were left homeless. This magnitude was 8.8. In 1950, in Tibet, at least 780 people killed and many buildings were collapsed. About 70 villages were destroyed, mostly by landslides, one of which blocked the Subansiri River. This natural dam broke 8 days later, creating a wave 7-meter high, which flooded several villages and killed 536 people. This was a magnitude of 8.6.
Make a summary of the image on the screen. Effects of certain events can be categorized into distinct groups. Primary: the short-term or immediate impact of an earthquake, such as damage or loss of life. Secondary: the long-term effects or effects which are caused later on as a result of the earthquake, for example, deaths as a result of a tsunami or fires that break out as a result of damaged gas lines. Social: any impact on people, for example, death, injury, or homelessness. Economic: any impact involving money such as repair costs and the loss of investment or income. Environmental: any impact which changes the surrounding area such as fires, tsunamis, or landslides. Case study: Japan earthquake and tsunami of 2011. Facts and information. On 11 March 2011, a magnitude 9 earthquake shook northeastern Japan, unleashing a savage tsunami. The effects of the Great Earthquake were felt around the world, from Norway's fjords to Antarctica's ice sheets. Tsunami debris continues to wash up on North American beaches 2 years later. Japan still recovering. In Japan, residents are still recovering from the disaster. Radioactive water was recently discovered leaking from the Fukushima Daiichi nuclear power plant, which suffered a level 7 nuclear meltdown after the tsunami. Japan relies on nuclear power, and many of the country's nuclear reactors remain closed because of stricter seismic safety standards since the earthquake. 2 years after the quake, about 300,000 people who lost their homes were still living in temporary housing, according to the Japanese government. Deaths: more than 18,000 people were killed in the disaster. Most died by drowning. Less than an hour after the earthquake, the first of many tsunami waves hit Japan's coastline. The tsunami waves reached run-up heights, how far the wave surges inland above sea level, of up to 39 meters at Miyako City and traveled inland as far as 10 kilometers in Sendai. The tsunami flooded an estimated area of approximately 561 square kilometers in Japan. Nuclear meltdown. The tsunami caused a cooling system failure at the Fukushima Daiichi nuclear power plant, which resulted in a level 7 nuclear meltdown and release of radioactive materials. About 300 tons of radioactive water continues to leak from the plant every day into the Pacific Ocean, affecting fish and other marine life. Worldwide effects. The tsunami waves also traveled across the Pacific, reaching Alaska, Hawaii, and Chile. In Chile, some 17,000 kilometers away, the tsunami was 2 meters high when it reached the shore. The surge of water carried tons of debris out to sea as it receded. Japanese docks and ships, and countless household items, have arrived on US and Canadian shores in the ensuing years. Why are some communities more affected by earthquakes? People's levels of exposure will determine how much the earthquake will affect them. Distance: the further you are from the focus or epicenter of the earthquake, the smaller the impact will be that you experience. Magnitude: the higher up on the Richter scale an earthquake is, the more damage it will cause. Development: more developed countries will have better access to emergency and basic services, communication, information, government support, and have more economic and political stability, as well as homes, buildings, and infrastructure of a far higher quality. This means that they will be far less at risk to the impact of the earthquake. Population: the more people there are in an area, the more the impact of the earthquake will be felt. This can also refer to urban or rural areas, as urban areas are generally far more populated than rural ones. Communication: areas which have easy access to communication can put up early warning systems and can also contact emergency services after the earthquake happens. Information: in areas where earthquakes happen often, people are trained and information about earthquakes are shared with the entire population. As such, they are far more prepared than areas which don't often experience earthquakes and are therefore less vulnerable to the impact of earthquakes. Environment: the natural environment of an area will have an impact on the vulnerability of that area as well. Mountainous and coastal areas are at risk of secondary impacts as a result of landslides, avalanches, and tsunamis. Look at the image on the screen. I helped you make a summary of why some communities are more affected by earthquakes. Write it in your books. Reducing the impact of earthquakes. There are various safety measures that people and governments can implement, which will reduce the risk and impact of earthquakes. Education. Knowledge is power in any situation, but particularly this one. People who live in earthquake-prone areas need to ensure that they know as much about earthquakes as possible. Governments need to ensure that people of all ages are trained in the correct way to act before, during, and after a disaster. Schools and businesses can do various drills, information leaflets can be handed out, and talks can be given at schools and businesses to ensure knowledge is widely shared. Communication. Many scientists are constantly monitoring seismic activity and are able to predict when an earthquake is likely to happen. While this does not completely mitigate the impact an earthquake will have on an area, an early warning system will ensure that some steps are at least taken. Effective communication will allow people to call for help and medical services. This can also be implemented at a family level, as family members are often separated during a disaster. Having a plan in place or a designated meeting area will help. Preparation. Preparation is vital, and households should always have emergency supplies such as a torch or first aid kit ready, in case of an emergency, not just for earthquakes. Households can also ensure that any hazardous objects or things likely to harm someone are stored away safely. Infrastructure. There are various ways of adjusting and improving infrastructure so that it is more resilient in case of an earthquake. Municipalities can plan future developments better, so that they are not near earthquake-prone areas. They could also place limitations on buildings, like in Japan where there is a height restriction on all buildings, or even control the amount of people living per square kilometer. This will ensure that fewer people are injured. The construction of buildings is even more important, as many buildings in these areas are made of wood rather than earthquake-resistant materials. Unfortunately, the construction of such buildings is expensive, which means that poorer communities are unable to improve infrastructure. They can, however, reinforce their current infrastructure by using steel in the foundations of buildings and using fireproof materials. Look at the summary of reducing impact of earthquakes. Summarize it in your books. The picture shows an earthquake-resistant building and the different features that help it stay safer during an earthquake. The building has cross-bracing, which means steel beams are placed in an X shape to strengthen the walls and stop the building from bending too much. It also has shear walls, which are strong concrete walls with steel bars inside them to reduce rocking movements. At the bottom of the building, there are shock absorbers, also called base isolators, which help absorb the shaking from the ground. The diagram also shows the ground and a moat around the base, giving the building space to move slightly during an earthquake without breaking apart. Overall, the picture explains how stronger building design can reduce damage and keep people safer during earthquakes. Earthquakes, factors affecting and reducing the impact. Every earthquake is different, but some factors can increase the impact, while others can help reduce it. Factors affecting the impact of earthquakes. 1. Development. More developed countries have better access to emergency services, communication, information, government support and higher quality buildings and infrastructure. This makes them less vulnerable. 2. Population. The more people in an area, the greater the potential impact. Urban areas are generally more populated than rural areas. 3. Communication. Easy access to communication allows for early warning systems and helps people contact emergency services after an earthquake. 4. Information. In areas where earthquakes happen often, people are trained and information is shared widely. These areas are better prepared and less vulnerable. 5. Environment. The natural environment can increase the impact. Mountainous and coastal areas are at risk of secondary hazards such as landslides, avalanches, and tsunamis. Factors reducing the impact of earthquakes. 1. Education. Training and drills in schools, workplaces, and communities teach people how to act before, during and after an earthquake, reducing panic and saving lives. 2. Communication. Early warning systems give people time to take action. Good communication also helps people call for help and allows families to stay in contact. 3. Preparation. Having emergency supplies, for example first aid kits, water, torches, and securing or storing dangerous objects can reduce injuries and damage. 4. Infrastructure. Building earthquake-resistant structures, reinforcing foundations with steel, using fireproof materials and planning safe developments make communities more resilient. Example: the USA. The USA has many areas near epicenters, dense populations, and often experiences earthquakes of high magnitude. Write the new words on the sheet with their pictures. Infrastructure. The basic structure and physical layout of something, which allows it to operate, for example. The infrastructure of a city would be the roads, pipelines, and buildings. Nuclear power. Power generated by a nuclear reactor. Nuclear meltdown. When the core of a nuclear reactor at a nuclear power plant overheats, often resulting in radiation escaping. Municipality. A city, town, or area with a local government. Richter scale. Measures the intensity of an earthquake. Debris. Any rubble or remains of buildings and material left after a disaster strikes. Radioactive. Producing a very powerful and dangerous form of energy, which releases radiation particles. Seismic activity. The frequency with which an area experiences earthquakes or tremors. Seismic safety standards. Laws implemented to control the quality of certain buildings and other safety standards, so that they can withstand earthquakes. Mitigate. To lessen the impact in a situation or lessen the severity of something. Reinforce. To strengthen or support an object with additional materials. Question 1. For this question, look carefully at the earthquake diagram and remember the main parts of an earthquake. You should first find the point on the surface where the earthquake is felt the strongest. This is called the epicenter. Then you should look underground for the place where the earthquake actually starts. This is called the focus. The lines or circles moving away from the focus show the seismic waves, because these are the waves of energy released by the earthquake. The crack or line where the rocks have moved is the fault. A possible answer is A. Epicenter, B. Fault, C. Seismic waves, D. Focus. Question 2. For this question, you must think about the different kinds of impact the 2011 Japan earthquake had. Social effects are impacts on people, economic effects are impacts involving money, buildings, jobs, or infrastructure, and environmental effects are impacts on nature and the surroundings. Primary effects happen immediately because of the earthquake itself, while secondary effects happen later because of something the earthquake caused, such as the tsunami or nuclear meltdown. In the table, a good answer could include, for primary social effects, people were injured, killed, or left homeless. For primary economic effects, buildings, roads, bridges, and railways were damaged. For primary environmental effects, the land and coastline were damaged. For secondary social effects, many people had to live in temporary housing or move away because of radiation. For secondary economic effects, Japan had huge repair costs and damage to services such as electricity, water, and transport. For secondary environmental effects, radioactive materials leaked into the environment and the tsunami carried debris into the sea. Question 3. For this question, you must name 3 reasons why Japan was vulnerable to this earthquake. Vulnerable means that Japan was at risk of being badly affected. You should think about Japan's location, the strength of the earthquake, and the natural environment. Japan is located near tectonic plate boundaries, which means it often experiences earthquakes. The earthquake was also very strong, with a magnitude of about 9, so it caused a lot of shaking and damage. Japan is also a coastal country, so it was vulnerable to a tsunami after the earthquake. A good answer could be, Japan was vulnerable because it is close to tectonic plate boundaries. The earthquake had a very high magnitude, and many areas are coastal, which made them vulnerable to tsunami waves. Question 4. For this question, you must think about what could reduce or lessen the impact of an earthquake. These are not the same as the factors that make a place vulnerable. Japan is a developed country, so it has good communication, emergency services, warning systems, trained people, and stronger infrastructure. These factors can help reduce the number of deaths and reduce damage. A good answer could be, early warning systems would have helped because they could warn people before the strongest shaking or tsunami waves arrived, giving them time to move to safer places. Stronger earthquake-resistant buildings and infrastructure would also have lessened the impact because buildings, roads, and bridges would be less likely to collapse or be badly damaged. Across 6. Radioactive. When something is radioactive, it gives off dangerous radiation particles. We often talk about this when discussing nuclear power plants, especially when there is damage or a nuclear meltdown. The answer is radioactive. Across 7. Richter scale. The Richter scale is used to measure how strong an earthquake is. The higher the number, the stronger and more destructive the earthquake can be. The answer is Richter scale. Across 9. Diverge. When tectonic plates move away from each other, we say they diverge. This movement can create rift valleys or allow magma to rise between the plates. The answer is diverge. Across 10. Converge. When tectonic plates move towards each other, they converge. This can cause mountains to form, or one plate may be pushed under another plate. The answer is converge. Across 11. Tsunami. A tsunami is a large ocean wave, usually caused by an underwater earthquake. These waves can travel very far and cause serious damage when they reach land. The answer is tsunami. Across 12. Pangaea. Pangaea was the supercontinent that existed millions of years ago, before the continents slowly moved apart because of continental drift. The answer is Pangaea. Down 1. Magma. Magma is hot, molten or semi-molten rock found beneath the Earth's surface. When magma reaches the surface, it is called lava. The answer is magma. Down 2. Mantle. Widest part of the Earth. It lies between the crust and the core, and it contains hot rock that moves slowly over time. The answer is mantle. Down 3. Crust. The crust is the outer layer of the Earth. It is the part we live on, and it is divided into tectonic plates. The answer is crust. Down 4. Focus. The focus is the place inside the Earth where an earthquake starts. It is where the built-up pressure is released. The answer is focus. Down 5. Core. The core is the deepest layer of the Earth. It is found at the center of the Earth and is extremely hot. The answer is core. Down 8. Earthquake. An earthquake happens when energy is suddenly released in the Earth's crust. This usually happens along faults where tectonic plates move, get stuck, and then suddenly break free. The answer is earthquake. Down 13. Epicenter. The epicenter is the point on the Earth's surface directly above the focus. This is often where the shaking is felt the strongest. The answer is epicenter. Lesson 7. Volcanoes. Volcanoes are a unique phenomenon in nature and form part of the Earth's life cycle, with approximately 50 eruptions per year. The Earth's crust is divided into 17 pieces called tectonic plates, which float on magma. If there is a weak spot in the crust, or when tectonic plates collide or scrape against each other and cause a gap in the crust, magma escapes through the crust to the Earth's surface. There are roughly 500 active volcanoes on Earth. Most of them can be found in what is known as the Ring of Fire. The Ring of Fire is situated in the Pacific Ocean and contains 75% of the Earth's volcanoes. 3 types of volcanoes can be formed, namely composite, cinder cone and shield volcanoes. The following lesson will teach you more about this phenomenon. Write the new word in your book. Volcano. A natural gap in the Earth's surface through which magma, gas, lava, or rock fragments erupt. Magma. A mixture of molten and semi-molten rock and particles beneath the Earth's surface. Lava. Molten magma flowing out of volcanoes. 7.1 volcanoes around the world. If you study the map below, you will notice that the majority of the world's volcanoes appear along the fault lines of the various tectonic plates. You will also see that they are heavily concentrated in what is known as the Pacific Ring of Fire and is named after the high volume of volcanoes along the edge of the Pacific Plate. This is because of the manner in which volcanoes are made. How volcanoes are formed. As we learnt in the previous unit, the Earth's crust is not solid. It is made up of a number of tectonic plates. The places where these plates meet are called faults or boundaries. They are a weakness in the Earth's crust. The plates are constantly floating on the magma of the upper mantle and this creates pressure. At times, the pressure is released in the form of an earthquake. At other times, the magma squeezes through this weakness in the crust and rests in the magma chamber. If the pressure builds up enough, the magma is pushed out at the top of the volcano. The force of this eruption spews ash and rock into the air. Noxious gases are also often released at the same time. The ash falls like snow and covers the land for kilometers. The type of eruption and the material that the magma consists of determines the type of volcano, as well as its size. There are 3 types of volcanoes: composite, cinder cone and shield volcanoes. Types of volcanoes: composite volcano, cinder cone, shield volcano. Look at the drawing on the screen of the diagram of a volcano. Draw this in your book, with all the labels. Make sure to add color to your drawing, and make sure your drawing is neat. Volcanoes today. Many mountains were formed by volcanoes. The islands of Hawaii were also formed by volcanoes. In fact, the islands are still growing because of the underwater volcanoes that formed it. However, volcanoes are generally classified into active, dormant, and extinct volcanoes. Active volcanoes still erupt regularly. Dormant volcanoes have evidence of magma, but have not erupted in some time, and extinct volcanoes are very unlikely to ever erupt again. Study the table that follows about how the most famous eruptions had an impact on the surrounding areas. You do not have to study this table for tests or examinations. Iceland. 2010. The volcanic ash caused a great deal of air pollution and, as a result, grounded hundreds of aeroplanes and caused most airports across Europe to close. This meant that thousands of passengers could not catch their flights and airlines and airports lost billions of rands. Democratic Republic of Congo. 2002. Despite many people being evacuated, there were still over 140 deaths because of asphyxiation caused by the gases released by the volcano. The capital city of Goma was covered in lava, which resulted in the closure of the international airport, damage to over 4,000 buildings, and over 100,000 people being left homeless. Mexico. 2000. Rock, ash, and smoke were strewn almost 4 kilometers into the sky and could be seen as far as Mexico City. Thousands of people were forced to evacuate to government facilities. Fortunately, there were no fatalities. Washington, USA. 1980. An earthquake caused Mount St. Helens to erupt. Not only was the original blast destructive, but lava mudflow destroyed kilometers of the forests surrounding the mountain. It also triggered some of the world's worst debris avalanches, which is a mixture of mud, volcanic rock, and snow, as well as a series of mudslides. Indonesia. 1815. This is one of the worst volcanic eruptions in history because the gases released by the volcano had such an impact on the climate that it caused a massive drought all over the USA and Europe. Not only were hundreds of people smothered in the molten lava that was released by the volcano, but the resulting acid rain led to famine and a death toll of over 90,000, the majority of whom died from starvation. Indonesia. 1883. This active volcano had one of the world's deadliest eruptions and killed roughly 36,000 people. Many of these deaths were caused by the waves of over 40 meters in height, which covered over a third of the island. Italy. 79 AD. The volcano had one of the earliest recorded eruptions and destroyed the ancient Roman cities of Pompeii and Herculaneum. Although the death toll was not as high as many other eruptions, approximately 4,500, it is one of the most famous as it covered the city of Pompeii in lava and ash. In question 1, you are asked to think about the effects that volcanic eruptions can have on people, animals, and the environment. A volcanic eruption can release lava, ash, smoke, poisonous gases, and rocks into the air. These eruptions can destroy homes, forests, and roads. Some eruptions even stop aeroplanes from flying because volcanic ash is dangerous for engines. Farmers can lose crops and animals, and many people may have to leave their homes for safety. Think about the case studies you studied and all the damage they caused. Answer: air pollution, destruction of homes, destruction of forests, deaths of people, injuries, damage to roads, closure of airports, people becoming homeless, crops being destroyed, poisonous gases being released. In question 2, you must name the parts of the volcano shown in the diagram. A volcano has different sections that help magma move from underground to the surface. The crater is the opening at the top. The magma chamber is where magma collects underground. The vent or pipe is the passage the magma travels through. Side vents allow magma to escape from the side of the volcano. The layers on the volcano are built from ash and lava after many eruptions. Study the arrows carefully and match the labels to the correct parts. Answer: A. Cloud of volcanic ash. B. Crater. C. Cone. D. Pipe or main vent. E. Magma chamber. F. Side vent. G. Ash layers. In question 3, the question asks whether there are volcanoes in South Africa. Volcanoes usually form near tectonic plate boundaries where plates push together or pull apart. South Africa is situated in the middle of a tectonic plate, so there is very little volcanic activity. This means South Africa does not have active volcanoes today. Answer: no, South Africa does not have active volcanoes because it is not situated near tectonic plate boundaries. In question 4, you are asked why the eruption of Vesuvius is one of the most famous eruptions in history. Mount Vesuvius destroyed the Roman cities of Pompeii and Herculaneum. Lava and ash buried the cities and preserved many buildings and objects for hundreds of years. Scientists later discovered the cities almost exactly as they were during the eruption, which made the eruption very famous. Answer: it is famous because it destroyed Pompeii and Herculaneum and buried the cities under lava and ash. In question 5, you need to name the 3 types of volcanoes. Remember the lesson about the shapes and eruptions of volcanoes. Composite volcanoes are tall and steep. Cinder cone volcanoes are smaller and formed from ash and rock fragments. Shield volcanoes are wide with gentle slopes because lava flows slowly over large areas. Answer: composite volcano, cinder cone volcano and shield volcano. In question 6, the question asks how earthquakes influence volcanoes. Earthquakes happen when tectonic plates move and create pressure underground. This movement can crack the Earth's crust and allow magma to rise to the surface. Sometimes earthquakes happen just before a volcanic eruption because magma is pushing upward through the crust. Answer: earthquakes crack the Earth's crust and allow magma to move upward, which can lead to volcanic eruptions. In question 7, you must decide whether each volcano is active, dormant, or extinct. An active volcano erupts regularly. A dormant volcano is sleeping and has not erupted in a long time but could erupt again. An extinct volcano is unlikely to ever erupt again. Look carefully at the pictures. Volcano A is erupting, Volcano B is sleeping, and Volcano C looks dead. Answer: A. Active. B. Dormant. C. Extinct. Volcanoes are formed by great force and magma is pushed to the Earth's surface. When magma reaches the surface, it is known as lava. Lava is dangerous, but not as deadly as the pyroclastic flow or ash cloud that runs down the volcano at a speed of up to 160 km per hour, destroying everything in its path. Although volcanoes are powerful forces of nature, they are also essential in the cycle of nature as they create new land where new life can flourish. Write the new rods in your books. Abnormal. Something which is unusual or out of the ordinary. Wake. The waves that are formed by something moving over water. Current. When a mass of water moves in a specific direction, for example, downstream. Fertile soil. Soil in which plants grow easily and which produces large harvests. Floodplain. A low-lying area of land next to a river. Hypothermia. When the body's temperature drops below the normal 37 degrees Celsius. The main reason floods occur is due to water levels rising higher than soil can absorb. In most cases this is due to heavy rains, which cause flash floods. Natural phenomena such as hurricanes, tsunamis, typhoons, and more can also cause heavy rains, which may result in floods. Other reasons for the rising water levels of rivers and oceans include changing rain patterns and snow melting at the poles. Coastal towns and neighborhoods close to the water are danger areas, and barricades and canals are usually built to direct water in different directions to prevent floods. Causes of floods. Floods are caused when there is more water than can be absorbed naturally by rivers, streams, and soil. This can be caused by a number of different things. However, humans have made so many changes to the landscape that the effects of floods are now more severe. 1. Heavy rain. Unusually heavy rainfall is one of the most common causes of floods. There are processes in nature that are there to deal with the amount of rainfall naturally. It involves the rivers, soil, and natural floodplains of the earth. Rainwater is generally absorbed by the soil. However, when the soil becomes saturated and can no longer absorb the water, the excess water flows over land. This water is known as the runoff, which usually flows into streams, rivers, or dams. However, soil erosion and deforestation caused by development disrupt this natural process. While indigenous vegetation helps the soil hold water, erosion causes the soil to be porous and it cannot absorb the correct amount of water. 2. Changes to the environment. The other natural drainage method is that rainwater flows into nearby rivers. All rivers have natural banks or sides and floodplains, which is the low-level land on each side of the river. However, because of how fertile this land is, people often build establishments on the floodplains. This is a problem, particularly with perennial rivers which often flood during rainy seasons. Developments further compound this problem as drain pipes, storm drains and gutters are not built to withstand the abnormal amount of water. The photo below clearly shows how developments are replacing the natural environment. 3. Other natural disasters. The abnormal circumstances created by other natural disasters can also cause floods. When there is an earthquake in the ocean, particularly one with a higher magnitude, it is likely to cause a tsunami. Tsunami means great wave in Japanese. When the energy caused by the tension in the fault is released, it causes large amounts of water to be displaced, and it results in massive waves that can reach heights of 65 m and speeds of 100 km per hour. These waves leave devastation in their wake and have far-reaching impacts everywhere, but particularly with flooding and drowning. Tropical storms, also known as typhoons and hurricanes, are also a major cause of flooding, as they bring with them far more water to a specific area than what is natural, which results in flooding and immense amounts of damage. In February 2017, Tropical Storm Dinio caused heavy damage in Mozambique, as can be seen in the photo below. Look at the summary on the screen about causes of floods. Make the summary in your book. Mankind's influence on floods. Influences of floods. Developments in wetlands means they can no longer absorb water as they should. Concrete bridges and river control prevents rivers from flowing naturally, and this causes floods. Concrete surfaces create runoff as they are unable to absorb water. Overgrazing and cultivation of land exposes the soil, making it harder to absorb the water. Deforestation causes soil erosion and increases the risk and impact of floods. Alien plants clog waterways, making it easier to flood. Plants not indigenous to South Africa are not built for South African weather and climate, thus upsetting natural processes. Erosion of soil fills up rivers, which become shallower and far easier to flood. Weathering due to human and mechanical traffic compounds soil and prevents the absorption of water. Make a summary of the information on the screen. Write all the new words in your books. Erosion. The general loss of rock and soil from the Earth's surface, often caused by reducing the quality of the soil. Indigenous. Naturally found in a specific environment or place, for example. The protea is a flower indigenous to South Africa. Agriculture. Any type of farming, such as breeding animals or cultivating or farming crops. Mechanical. Something completed by machines. Alien plants. Plants that are not indigenous or natural to a certain area, for example, imported plants such as bluegum trees. Weathering. The breakdown of the size of matter particles over a period of time, e.g., rock is weathered down to grains of sand. Runoff. Water that flows over the Earth's surface after rain. Deforestation. The process during which forests or plants are removed so that the land can be used for something else. Flash flood. Flood that occurs with little or no warning. The effect of floods. Injury and death. As a person can drown in as little as 5 cm of water and get knocked off their feet by as little as 15 cm of water, it stands to reason that floods have a devastating impact on people. This impact is felt most severely when a flash flood occurs. A flash flood occurs with little or no warning beforehand. This is particularly common when an earthquake or tsunami occurs and results in thousands of injuries and deaths by drowning. Disease. Disease, especially cholera, is one of the many dangers floods hold for mankind. Diseases are usually rampant in areas affected by floods, as floods damage water supply and sewage systems. The abundance of water has many factors which lend itself to disease. Besides drowning, water also causes hypothermia and increases a person's chances of catching a virus or respiratory infection. It increases the amount of waterborne diseases and diseases such as malaria. Burst water pipes and destroyed infrastructure mean that people have limited access to a fresh water supply and medical facilities, leading to them drinking contaminated water and eating contaminated food. This means that there are many cases of cholera and diarrhea, which spread rapidly and further aggravate circumstances. Displacement of people. Floods often force people to flee from their homes because of the danger and the damage caused by them. Entire towns and communities have to leave their homes because they are unable to survive otherwise. Many people tend to move towards higher ground when it floods, but it takes weeks and even months for the water to be absorbed, and by that time the damage to the infrastructure and the buildings of their hometowns are too severe for them to return safely. Many people in rural areas are subsistence farmers. When they lose their land due to floods, they have to move to places where they can live and find work. Damage. As stated previously, floods can cause a massive amount of damage, and they often have a severe impact on both the natural and man-made environment. Natural environment. The natural environment suffers along with the man-made one, despite water being a part of nature. The fast-flowing floodwaters often lead to more erosion than is natural, and it carries the soil far from where it originated. This can further compound any blockage problems that already exist and can have a twofold effect. While the positive impact is that farmland can sometimes receive fertile soil from the floodplains, the negative impact is that debris can be spread over a large area and the soil can end up in inappropriate places and cause further damage. Man-made environment. The damage to buildings and infrastructure is often extreme because of the high speed and the power of floods. It has the ability to wash away bridges, move or flatten houses, damage or destroy roads, railway lines, and pipelines. Hospitals can be destroyed and schools may be closed temporarily. Pace the activity and answer the questions. Why are some communities more vulnerable to floods? Distance. People, particularly poorer people, tend to build their settlements closer to rivers. There are two reasons for this. Not only is it an easily accessible source of water, but the land is often fertile. However, any abnormal weather patterns could cause the river to overflow and flood its banks, thus destroying crops and communities. Global warming. Places that are built close to or at sea level are easily flooded when there is heavy rain or tsunamis. Global warming has caused the polar ice caps to melt and it has raised sea levels. This has had a significant impact on the number of floods that occur. This image shows how Antarctica's sea ice has changed over time. As you look from 1979 to 2025, you can clearly see that the amount of ice around Antarctica becomes smaller and smaller. This happens because the Earth is getting warmer, which is called global warming. Warmer temperatures cause ice to melt faster, leading to more open water around the continent. The image helps you understand how climate change affects the environment over many years. It also shows why scientists are concerned about rising sea levels, changing weather patterns, and the impact this may have on animals, people, and ecosystems around the world. Antarctica in 1979. Satellite imagery from 1979 shows Antarctica with extensive sea ice surrounding the continent. Antarctica in 2005. By 2005, there is a noticeable reduction in sea ice extent around Antarctica. Antarctica in 2012. In 2012, even less sea ice is visible, especially around the edges of the continent. Antarctica in 2025. By 2025, sea ice has continued to decline, showing more open water around Antarctica than ever before. Information. In areas where floods happen often, people are trained and information about floods is shared with the entire population. As such, they are far more prepared than areas that don't often experience floods, and are therefore less vulnerable to the impact of floods as they know how to act when it happens. Development. Human development in certain areas disrupts the natural flow of the water. People have also forced many rivers to go off their natural paths and have built artificial reservoirs to supply urban areas with water. Preparing and responding to floods. Preparation. It is always best to be prepared. Communities need to be warned beforehand and evacuated to a safe place if possible. During Hurricane Katrina, which hit the USA in August 2005, approximately 1.5 million people out of 1.7 million were evacuated before the hurricane reached the coast. Emergency services should also be alerted so that they can be better prepared to deal with the casualties resulting from the floods. Temporary or government housing and facilities could be set up for people who will be affected by floods. However, people can prepare at home as well. Families should ensure that they have a plan of action in the case of a flood. It could include that each family member packs a bag with valuable items, emergency supplies, important medication, and a change of clothes to carry with them in case they need to evacuate their home. Reaction. People's reactions before and during any disaster can often dictate how they will experience the aftermath. If families are prepared and have a plan in place, they will be more likely to survive. People should remember that the water is dangerous even if it looks calm. Currents are not always visible and can be strong enough to move heavy objects. Currents can also injure them or even pull them from shelter, causing them to drown. Pace the activity and answer the questions.